This lesson is going to be about identifying and graphing polar equations without the use of a calculator. And so you may still want to get out the information from our notes from 8-3 that show you each form of the equation and their names. And we'll talk a little more detail about how each of those graphs can be formed from the numbers that we are given. So with this first equation, if you're looking at this set of notes, we can see that this equation kind of matches up with the Lemma equation right here. A is going to be 1, B is 2, and it's the cosine of theta. We have a plus sign in between. So let's talk about these different types of Lemma. The first thing the notes from yesterday told us was that when we divided A by B, if it was less than 1, equal to 1, in between 1 and 2, or greater than or equal to 2, it made a difference as to the shape. So for us, A divided by B, this is A, this is B, A divided by B is going to be 1 over 2. So we get 1/2, which is less than 1, which means we're going to end up with one of these with the inner loop in it. So let's go ahead and label this. This is going to be a Lemma with an inner loop. All right, so in more detail, here's some things that we can determine from our coefficients. First of all, if this is positive, then our graph is going to move out on the positive x-axis because it's a cosine. If it were a sine, it would be the positive y-axis. That's where the bulk of our graph will be. So the main part of our graph, it's going to look like this one. And in addition to that, if you take the coefficients and you add them, in our case we get 3, that's going to be the diameter of your Lemma. Of your Lemma. And then if you were to subtract those and get 1, that's going to be the diameter of the loop. So this is the overall diameter. This is the diameter of the loop. So we're going to go out 1, 2, 3 units. We're going to go 1 unit out for the little loop. Okay. So our graph is going to do something like this. I don't know if I can do it in a smooth motion. Should have been bigger. Sorry about that. Okay, so try to ignore this little line right here. I didn't mean to draw that one. So it's going to look similar to that. The loop itself will be the difference, and the diameter, how far out we're going to go, will be the sum. All right, so the second one, we have 3 minus 4 sine theta. That looks like this equation right here. So we still have a Lemma, and A over B is going to be 3 over 4. So we're still less than 1, which means we still have a loop. It's still going to be a Lemma with an inner loop. But this time it's negative, which means it's going to be, and it's a sine. So sine is either going to be on the positive y or the negative, in this case, the negative y-axis. So if I add, I'm going to get my diameter. So 3 plus 4 is 7, so 7 units down. And then if I subtract the diameter of the loop, it's going to be 4 minus 3. It's 1. So always we're going to take the positive. So the loop is going to be 1 unit. So just take big number minus small number. We're going to have 1 unit loop again. So let me try and see if I can do this one a little bit better. So we have our loop, come up, go around, Oh, here's my point. And back. So something like that. All right. So example 3, we have 2 minus 2 sine theta. 2 minus 2 sine theta. Well, again, it looks like these equations. 2 minus 2 sine theta would look similar to this. So let's check out our a and b values again. A divided by b is going to be 2 over 2, which is 1 unit. So it says here that when it's equal to 1, we're going to have this cardioid, which just has this point. Okay, so a little bit different. Now on this one, so let's go ahead and name it. This one is the cardioid limicon. Okay, and we're still going to add to get our main diameter, which is going to equal 4. 2 plus 2, 4. But this one, we're not going to subtract because there's no loop. I mean, 2 minus 2 would just give us 0. But this number in the front here, this number is going to tell you how far out to go on the x-axis. This diameter, remember, because this is a sine graph and it's negative, it's going to be on the negative y-axis. So we're going down 1, 2, 3, 4. This is going to be the diameter. But this 2 in the front, that tells you how far out to go on the x-axis, left and right. And remember, it's dipping in here to make that little heart shape, but it is kind of rounded on the other side. So it's going to look something like that. This comes from here, the number in front. All right. So negative puts us on the, sine puts us on the y-axis. Negative puts us on the negative y-axis. All right. So next one, still the same type of form. This time we've got a cosine. And a over b is 3 over 3, or 1 again. So it's still going to be a cardioid. But this one's going to be on the x-axis. So our diameter, we add them up, 3 plus 3 is going to be 6. So 1, 2, 3, 4, 5, 6. And the number in front is going to tell us how far to go up and down this time. Remember, we come down to a point, and then we have the rest of our graph. All right, so remember, the number in front here tells us, how far coming out this way. All right, next one, we've got 5 plus 2 cosine theta. 5 plus 2 cosine theta, still the same limicon, but this time a over b is going to be 5 over 2, or 2.5. So that's going to be like this one, greater than or equal to 2. So we have a convex limicon. Okay, we're still going to add and subtract. Add, we get 7. Subtract, 5 times 2, we get 3. And that tells us how far out we are going each direction. Now this one's the cosine, so it's going to be on the x-axis. So we're going out 1, 2, 3, 4, 5, 6, 7 to the right. Because it's positive, that's going to be your bigger side. And out on the other side, we're going out 1, 2, 3 to the left. This 5 tells us how far we're going up and down. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. So this one's going to be flat. Remember, there's no dimple or indentation on this side. We're coming up to this point. We're going out to our 7, same thing down this way. So it looks similar to this. So our 7 out, our 3 out, and then the 5 tells us about this amount in here. All right. This one is 2 minus, this is understood to be a 1 sine theta. So we're still 2 minus 1 sine theta, still have a limicon. This one, we have A over B is 2 over 1, or 2. So this one is a convex limicon. All right. So on this one, we're going to add and get 3, subtract, we get 1. This one is negative and it's a sine, so it's going to be the bigger part on the negative y-axis. So down 1, 2, 3, 1 unit up. And then the number in front, remember that tells us how far to go left and right. 2, 2, kind of flat across the top. We're coming down here, around, back up through, and back to our point. Okay. All right, for our next graph, we have r equals 2 cosine of 3 theta. So 2 cosine 3 theta looks like one of our rose curves. 2 cosine 3 theta. So this one's going to be a rose curve. And we even talked about this part in the notes yesterday whenever we were doing the 8-3 notes. We talked about if n is going to help us determine the number of petals. And so in our equation, n is 3. So just like this one, n is 3. We're going to have 3 petals. All right. So the number in the front here, that's going to give us the length of our petal. The number in front of theta tells us the number of petals. Because it is a cosine, but then we're going to be starting our first petal on the x-axis. So it's 2 units out. And so our petal comes out like this. But remember that on this one, they are all spaced evenly, so it's going to be in thirds. So this is going to be a third and a third. So these are where my other 2 petals go. So I go 2 units out this way and 2 units out this way. Now, since it's on the diagonal, we can't really go out 2. We just have to estimate 2 units. That was probably a little too small, but anyway, 2 units long is going to be the length of each of these petals. 1, 2, 1, 2. All right, for our next one, this is still going to give us the length of the petal. Well, first I have to identify that it's a rose curve, but it's the same formula, so this one is a rose curve. But it is a sine, and on the sine, when we have an even number, then it looks like we are going to double the number of petals. So because in here in this example was 2, there were 4 petals. So whatever this is, if it's an even number, then we're going to double that number. In our case, just doubling 2, we get 4 petals. Now, as a sine, remember, when this was even, and we ended up with 4 petals, then these petals were on, they start on y equals x, or on the diagonal. So we're going out 3 units, 1, 2, 3 units on the diagonal. 1, 2, 3 units on the diagonal. 1, 2, 3 units. 1, 2, 3, and we're just kind of estimating here. But we know that we're going to end up with 4 petals. They're all supposed to be the same length, same shape, same size. Not the best artist here. So there we go. All right. So for our next one, we have 3 sine theta. So it still looks very similar. But on this one, there's no number in front. So this, maybe you would recognize this one as one of those we've already graphed. This is just 3 sine of theta. Let's look down here. 3 sine of theta is actually just a circle on the y-axis, since it's a sine. If it's a cosine, it would be on the x-axis. So this one is going to be a circle. I guess I need to write that. And it's on the y-axis. So this number is the diameter of my circle. We did these a few lessons ago. So we're just going up 1, 2, 3. And we're drawing in our circle. So 1.5, I'm just going to approximate so I can kind of try to draw a good circle. All right. The same with this next one. This one doesn't have that number in front. It's not a number of petals. It's just a circle again. This one is a cosine. So this one's going to be a circle on the x-axis. But because it's a negative number, it's going to go to the left. So 1, 2, 3, 4, 5 units to the left. So 2.5 is the center. So 1, 2, maybe right here, right here. I'll try to draw a circle. All right. So those we've already done. Those are pretty simple. All right, these last 2 are the r squared ones, so we're probably going to recognize those pretty quickly as the lemniscate equation. So let's see how these are going to work out for us. Remember, if it's sine, it's going to be on the diagonal. If it's cosine, it's going to be on the x-axis. All right, so here's what we're going to do with those. This number here in front, we're going to take the square root of that number, which in this case gives us 3, and that's going to be the length of the petal. Because it is a sine, like I said, it's not going to be on the x-axis, it's going to be on the diagonal. And, well, I guess we need to name it. This one is a lemniscate. All right. So again, we're just going to estimate going from the center out. 1, 2, 3. Get a petal. And going out the other. 1, 2, 3. Lemniscates are only going to have those 2 petals. All right. Again, lemniscate. Square root of 4 is 2, so that's going to be the petal length. This one is a cosine, so it is going to be on the x-axis. So we're going to go 2 units to the right, 2 units to the left, we go. So if you can identify the equation using our notes 8.3, then you can use these notes to kind of help you with what the shape is going to look like, and then tie that into what we've just done with, with your limicons. You want to add your coefficients and subtract your coefficients to determine loops and diameters. Also, the number in front on the cardioid and the convex will help you with how wide to make your graphs.